Okay, and here we go with the scatter graphs one. Little or no correlation that matches up to this graph, and weak positive correlation matches to this graph. There's nothing for these two, so there we go. That's question one. Question two, here are three scatter graphs. Which one has the strongest correlation? So the strongest correlation has got more of the points closely following the line. That has got to be graph B. And which graph should not have been drawn? And that's A. And the reason has got to be there is no correlation. Okay, let's go on to question three. So we've got to, for this one, we can see here we've got this. They've told us that there is a strong positive correlation here. And what does that mean? Well, that means the higher you get in the first test, the higher you get in the second test. So higher in first test means higher mark in the second one. In the first test, Hannah gets 38%. That's good for her. Find her mean percentage in the two tests. So we've got to work out what she would get in the second test first off. So we've got 38 there. So let's take my ruler and we're going to go up to the line and we're going to go across. We can see we've definitely got that she's going to get 26 there. We've got to find the mean in the two tests. So we've got 38 plus 26, so that is 64. Now we just got to halve that because we've got two tests. So 64 divided by 2 means 32 for Hannah. On to question 4. So we've got a graph drawn, it's got a line of best fit, and we're talking about advertising and revenue. Work out use line of best fit to work out the revenue of advertising costs of only 600. I'm going to go to just a more narrow line here just to be super accurate. So 600, that's only down here, and we can go up and across, and we're looking at about 18,000. So allowing you 18,000 to 18,500. I'll write that in a second. If it was the advertising cost was 6,200, that's here, and so we're going to go up to that line and across there. So it's the answers that we're going to want to read off. It's going to be the ones here and here. So for this one, we're after anything from 18,000 up to 18,500, and that's inclusive. And for this one, we're looking for anything from 40,500 up to 41,000. It's quite demanding on what it asks for accuracy. So I would say be a bit more lenient for yourself if you printed this out on like A5, because it would be a bit harder. But on A4 size, you need to be able to do that. Okay, next one. Which of these is more reliable? And it's the second one. Or the £62,000 one, and that's because it's within the range of given data. So for 62,001 because it's within the range of given data, because for this one there was nothing like the smallest amount of spending on advertising is sitting down here at about 1,400. There's none of these companies did on no occasion did this company spend less than £1,000 on advertising, so it's a bit difficult to draw conclusions for that. Whereas this one, the second one, 6,200, is slap bang in the middle of what they would normally do, so that's a fair enough conclusion to draw. Okay, on to question 5. We're now looking at the archery game at the school fair. He wants people to shoot arrows at different distances and gets this data. Okay, he wants to make a 60% profit. Okay, so we're going to say if he's going to make a 60% profit, that means he's going to want to win 60% of the time. So you want to miss the target 60% of the time. So that's going to be in here at 40%. We need a line of best fit first. So let's just have a little go at drawing one of those on. Something that's not bad, is it? Okay, and then we're going to want to go across from 0.4 and down. So I'm there. I'm thinking he wants to put that about 22 meters, give or take. As long as your line of best fit is good enough, I'm going to say 22 meters, but you know, I'll probably let you have, say, sort of 20 to 24 inclusive. I'll be nice, but as long as you've got a line of best fit there, that's okay. Right, for question 6, this time line of best fitted. I've put these two gates here to sort of use a skiing analogy, and your line of best fit has to kind of go through those in order to get your mark for this. So let's just put line of best fit on there first, to be something like that. And we've got to get one more bit of information on there first, so we better do that. Leaves work at 5:17 and arrives home 5:51. So how long does that take? Let's do a quick subtraction. 51 takes 17 is 34. So it's going to take her 34 minutes if she leaves at 5:17. So that is not bad, is it? Just a little bit below my line of best fit just there. Okay, then on this other one she leaves work at 5:12. 5:12, that's here, and estimate the time that she will arrive home. So up we go. Oh God, don't do that. Do not do that. Use a ruler. And up we go. One time I'll get it right. From 5:17, going up and going across there, and so I'm reckoning that's taken her about 33 minutes, 33 or 34 minutes. So you've got 5:12 plus 33, that's going to give us 5:45. But you know, depend on where you're drawing your line of best fit. As long as you've got a good line of best fit that goes through the gates and you've gone up to it and across, you can have your 3 marks. The mark scheme reckons you're in 5:44. Well, close enough, I think. Okay, last bit was question 6C. So one day she works late and doesn't leave until 6. 2 reasons why we can't use the scatter graph for this. So firstly, it will be outside the range of given data. So that says outside the range of given data, okay, because our data which only goes up to 5:30. And the second reason is traffic conditions would have changed. Okay, so she's just collected this data. This is just within the rush hour period. So once you get to sort of 6 o'clock, then a lot of people have got home. The roads will not be quite so busy. And that is that.